Measuring the turbidity of water. Turbidity is the cloudiness of a liquid caused by particles that are usually invisible to the naked eye. Turbidity can vary. Some waters can be very clear, others can be very cloudy. For example, the turbidity would be high in a river full of mud and silt where it would be near impossible to see through the water, whereas by comparison it would be low in clear spring water. Measuring the turbidity of water is an important test of its quality, as it is one of the methods of determining whether or not it is safe to drink. Pathogens harmful to human health can be suspended in turbid water. The World Health Organization, WHO, notes that managing turbidity is important for other reasons as well. Turbidity affects both the acceptability of water to consumers and the selection and efficiency of treatment processes, particularly the efficiency of disinfection with chlorine. In this film, we look at three methods of measuring turbidity in the field: measuring turbidity with a turbidity tube, the Chinese method, and measuring turbidity using a turbidity meter. The first two methods are simple means of measurement. The third involves the use of an electronic device that is more complex to use, but is a more accurate means of measurement. First, however, there is a rudimentary means of determining whether a liquid is a solution or a suspension by shining a light through it. This is known as the Tyndall effect. Named after the 19th century physicist John Tyndall, the Tyndall effect relates to the scattering of light by particles in a suspension. Discoloration in water can be caused either by suspended or dissolved materials. Dissolved materials cannot be removed as easily as suspended materials that can be removed by filtration or settlement. If a liquid is a solution, such as this jar containing fluorescein, the light from this laser is not scattered. It passes straight through. We cannot see the beam of light. The solution is coloured, but the colour doesn't scatter the light. If we look at milk in water, this is not a solution, it's a suspension. There are tiny globules of fat suspended in the water, so as we shine a light through it, we notice the light is scattered, confirming that it's a suspension and not a solution. Here we have iron in water. It looks coloured, and again, as we shine light through it, the light scatters. It's rather like car headlights on a misty evening. You can follow where your headlights are pointing because the tiny water droplets in the atmosphere scatter the light. So, this is a solution, no scattering of light. This is a suspension, light is scattered. The Tyndall effect is useful for determining whether a liquid is a solution or a suspension. This may help us to decide how to treat the water, but it does not tell us how turbid the water is. We turn now to the three methods of measuring turbidity. We have some fairly dirty water here, but we don't know how dirty or turbid it actually is. We'll look at the first means of measuring turbidity using a conventional turbidity tube. This is what a turbidity tube is: a long, thin, transparent tube made of two parts that fit together so that it is easy to carry. Note that once it has been assembled, it should always be held by the bottom section to prevent the connection coming loose. There are graded marks etched on the tube. See that this scale is not linear. The distance between 5 and 10 is much more than between 100 and 200. This is a scale we use for taking a reading using the turbidity level. A typical unit of measurement is the nephelometric turbidity unit, or NTU. There are other units of measurement, but we use NTU here, as WHO make recommendations for drinking water quality based on the NTU scale. The turbidity tube is a method for determining the amount of cloudiness, or turbidity, in a solution based upon measurement of the effect of this turbidity upon the transmission and scattering of light. For example, clear water in a stream will have good light penetration and therefore a high transparency reading on the turbidity tube, which in this example is 5 NTU. whereas a muddy or dirty stream will have poor light penetration and therefore a low transparency reading on the turbidity tube, such as 200 NTU. An important component of a turbidity tube is a black cross or a circle marked on a yellow or white background located inside the tube at the base of the lower section. The way we measure turbidity is simply to see at what level the cross or the circle becomes invisible to the naked eye by adding incremental amounts of turbid water into the tube until this point is reached. If the water is very turbid, the depth of the water column inside the tube will be much shorter than if the water has low turbidity. In this example, we have a high turbidity reading of between 40 and 50 NTU. The Chinese turbidity tube is slightly different in that it uses a standard depth of water rather than changing depths of water. The advantage here is that the tube can be much smaller than the conventional turbidity tube, although it may be less accurate. If the water is very turbid, it may not be possible to read any characters, and if the water is very clear, it will be easy to read even the smallest characters. To use this method, place the tube filled with your turbid water on top of the supplied chart of letters, then lean over and look through the tube at the visible larger characters printed on the chart. Next, slide the tube carefully across the chart towards the smaller characters until the characters can no longer be seen. Take a reading from the chart at this point. In this example, the reading suggests that the turbidity is somewhere between 40 and 50 NTU. To test turbidity to a high degree of accuracy, less than 5 NTU, then turbidity meters can be used. There are various types available on the market. Some are handheld for ease of use in the field, but they all work in a similar way. This is a desk-based turbidity meter, where everything is done automatically, eliminating the subjectivity of the vision of an observer looking through a tube. A beam of light is shone through the water, and the turbidity is calculated by comparing the intensity of the light before and after it enters the water. Here you take a sample of the water to be tested, placed into a tube designed to fit snugly into the machine. Fill the tube with the turbid water up to the white line near the top of the tube and screw the cap onto the top of the tube. There is a small white triangle on one side of the white line. This triangle should point towards you when the tube is inserted in the turbidity meter. Next, clean the exterior of the tube, as you want to measure the turbidity of the water and not the cleanliness of the glass tube. Opening the lid of the turbidity meter, place the sample tube into the circular slot provided in the machine, with the white triangle still facing towards you. Close the lid and wait for the turbidity reading to appear on the display. In this example, it records a reading of 29.4 NTU, which is reasonably clear. Water with a reading less than about 30 NTU could be treated by filtration without causing too many problems. Water having a turbidity of more than about 30 NTU can cause filters to clog. To check that the meter is calibrated correctly, and therefore to validate the reading for this sample, take the sample out of the machine and check the turbidity meter using one of the boxed standard tubes, each of which has a different NTU value. This particular standard tube has a turbidity of 20 NTU. First, shake it well to make sure that the material causing the turbidity is evenly distributed. Let it stand briefly for any bubbles to disperse and also clean the glass. Again, there is a line and a small triangle marked on the test tube, this time in black, and this should face you. This standard tube should have a turbidity of about 20 NTU, as previously specified on the label. Here it reads 21, but as it settles, it decreases towards 20. So this standard tells us that the turbidity meter is calibrated correctly. Turbidity is likely to change, and readings seldom need to be quoted to any great accuracy.